Watch toothpaste ads carefully and you will notice that many toothpaste contain fluoride. Now you must be wondering, why fluoride? What does fluoride have to do with dental hygiene? Let us find out in today's episode. Hi, you are in the studio with me, Devabrata Goswami, and today we will discuss the topic Solubility Product. In this episode, we will discuss solubility as well as get introduced to the concept of Solubility Product. Then we will solve some numericals based on these concepts and wind up with the exam decoded section. All of us have dissolved salt and sugar in water to make nimbu pani. So we all know what solubility is. But there is more to solubility than just dissolving salt or sugar in water. Today we will be discussing its nuances. And you may have come across one of them while making nimbu pani. When you mix the first spoonful of sugar in a beaker of water, it dissolves easily. But if you keep adding sugar, a stage will come when it will no longer dissolve. So we can say that the maximum amount of sugar in a given amount of solvent at a given temperature has been dissolved. And this gives us the solubility of sugar. So we define solubility like this. Solubility is the measure of the maximum amount of solute that can be dissolved in a given amount of solvent at a specific temperature. We chemists have a saying, like dissolves like. Yes, that means that when two substances have similar intermolecular forces, they are likely to be soluble in each other. When we mix carbon tetrachloride and benzene with each other, we find that they mix readily. That is because both these liquids are non-polar. See? But if we add oil to water, we see that they don't mix. Have you ever thought why? This is because water is polar while oil is non-polar. So they are immiscible. Remember, we talked about fluoride and its connection with toothpaste? Well, let's see how they are related. When food lodged between teeth decomposes, it produces acids. These acids react with a mineral present in the tooth enamel called hydroxyapatite. Since hydroxyapatite is soluble in acid, the enamel gets depleted. But when we brush our teeth with toothpastes containing fluoride, the fluoride replaces the hydroxide in hydroxyapatite to produce fluoroapatite and calcium fluoride. Both these salts are less soluble in acids than the original enamel. So, principles of solubility are used to protect our teeth and help prevent decay. Quantitatively, the term solubility means the amount of solute that forms a saturated solution with a given amount of solvent at a specific temperature. We know that a saturated solution is a solution in which maximum amount of solute has been dissolved. For example, carbonated water is a saturated solution of carbon dioxide in water, and it is the major component of most soft drinks. Take a look at this graphic to understand what solubility is. In the graphic, you can see solute being dissolved in water. As you see, the solute keeps dissolving till a saturated solution is formed. Once the solution is saturated, no more solute can be dissolved in it. Thus, we can say that in a saturated solution, equilibrium exists between the undissolved solute and the ions in the saturated solution. Now that we know what solubility is, let us discuss the factors on which solubility of a salt depends. The first factor is temperature. Each salt has a characteristic solubility which depends on temperature. Let me show you. I am sure you have all noticed that more sugar or salt dissolves in hot water than in cold. This holds true for most substances. That is, most substances are more soluble in water at a temperature higher than normal. It is obvious that the nature of a solute affects its solubility in water. Water, being a polar solvent, dissolves polar substances. On the basis of their solubility, we classify salts as soluble, slightly soluble, and sparingly soluble. Solutes are considered to be soluble if their solubility is greater than 0.1 molar. An example of such substances is sodium chloride dissolved in water. Solutes are considered to be slightly soluble if their solubility is between 0.01 to 0.1 molar, and sparingly soluble if the solubility is less than 0.01 molar, as in the case of silver chloride. I am sure you have grasped all that I have explained till now. We will now talk about sparingly soluble salts. Consider a sparingly soluble salt like silver chloride, which is in contact with its saturated aqueous solution. The equilibrium between the undissolved silver chloride and its ions in a saturated solution can be represented by equation 1. Recall that the equilibrium constant K is defined as the ratio of the product of the equilibrium concentrations of the products to that of the reactants, with each term raised to the power equal to the stoichiometric coefficient of the substance in the balanced chemical equation. So in this case, the equilibrium constant K will be given by the product of the concentrations of silver ion and chloride ion divided by the concentration of silver chloride. Note that square brackets refer to molar concentration. Since AgCl is a sparingly soluble salt, the concentration of the undissociated solid AgCl is constant. The product of K and the concentration of undissociated solid is known as the solubility product and is denoted by Ksp as shown. Thus we define solubility product of an electrolyte at a specific temperature as the product of the molar concentrations of its constituent ions, each raised to the power equal to the number of its ions produced on dissociation of one molecule in a saturated solution. So far we have discussed what solubility is, the factors affecting solubility, sparingly soluble salts, and solubility product. But here is more to come. So stay tuned while I come back after a short break. But till then, you can think about this question. What are the experimental techniques that can be used to determine the solubility product of a sparingly soluble salt? For more questions like these, you can log on to www.topperlearning.com, and for the answer to this particular question, just wait till I come back. Welcome back. I am Devabrata Goswami. You are watching Chemistry. And today we are discussing solubility product. Before the break, I had asked you what are the experimental techniques that can be used to determine the solubility product of a sparingly soluble salt. Well, some of the techniques we use are titration, spectrophotometry, and gravimetry. Moving ahead, let's write the expression for solubility product of magnesium fluoride. Taking a look at the formula of magnesium fluoride, we can easily see that on dissociation, 1 mole of magnesium fluoride gives 1 mole of magnesium ion and 2 moles of fluoride ions. Therefore, its solubility product is given by the product of concentration of magnesium ions and the square of concentration of fluoride ions. I hope the concept of solubility product is now clear to you. So let's move ahead and understand what molar solubility is all about. There are two ways to express the solubility of a substance. The solubility of a substance can be expressed in terms of moles per liter or grams per liter. Molar solubility is the number of moles of solute in 1 liter of saturated solution and is expressed in moles per liter. Solubility can also be expressed in terms of grams of solute in 1 liter of saturated solution. Both molar solubility and solubility in terms of grams per liter can be used to determine the solubility product. So let's calculate the solubility products from solubility data. We know the solubility of a compound. From that, we calculate its molar solubility. We then calculate the concentration of cations and anions and use them to calculate the solubility product. I think one of our viewers has a doubt about this.
Hi Devabrata, I'm Ankit. We know how to calculate the solubility product of a compound, but what can we know about the compound if we only know its solubility product?
That's a very good question. If we know the solubility product of a compound, we can calculate the concentration of cation and anions from the solubility product and then calculate molar solubility. I hope that answered your question, but if not, let me explain with an example. Consider a salt AXBY having solubility S. AXBY will dissociate to give X moles of AY plus ions and Y moles of BX minus ions. Here, AY plus and BX minus denotes the positive and negative ions respectively, and X and Y represent the number of these ions in the formula of the salt. According to this explanation, since the solubility of AXBY is S, the concentration of AY plus becomes XS and concentration of BX minus becomes YS. Substituting the values in the expression of solubility product, we get KSP as the product of XS raised to the power of X and YS raised to the power Y. Solving this, we get the value of S as given by this expression. When the salt is AB, that is X and Y is equal to 1, the expression for S reduces to square root of KSP. Let us solve a numerical to understand this concept better. A typical numerical could be something like this. The solubility of silver chloride is 1.06 into 10 raised to power minus 5 moles per liter at 298 Kelvin. Calculate its Ksp at this temperature. See, for every mole of silver chloride that dissolves, 1 mole of silver ion and 1 mole of chloride ion are produced. Since solubility of AgCl is 1.06 times 10 raised to power minus 5 moles per liter, therefore concentration of silver ion in the solution will be 1.06 times 10 to the power minus 5 moles per liter. Similarly, the concentration of chloride ion must be 1.06 times 10 to the power minus 5 moles per liter. Now we can calculate the solubility product of silver chloride. The solubility product is equal to the product of concentration of silver ion and chloride ion. So, let's substitute the values and calculate the answer. Yes, the solubility product of silver chloride at 298 Kelvin is 1.12 times 10 to the power minus 10. It's been going great till now, and it's only going to get better. If you haven't grasped any concept, wait till I meet you at the other end of the break with the recap and the exam decoded section. And for more chemistry logic, log on to our website www.topperlearning.com. Welcome back. I am Devabrata Goswami and you are watching Chemistry. Let us now recap all that we have learned today. Today we learned that solubility is defined as the amount of solute that forms a saturated solution with a given amount of solvent at a specific temperature. A saturated solution is a solution in which maximum amount of solute has been dissolved. Solubility increases with temperature and can be expressed in moles per liter or grams per liter. Solubility product of an electrolyte at a specific temperature is defined as the product of the molar concentrations of its constituent ions in a saturated solution. Here, each concentration term is raised to the power equal to the number of its ions which are produced on dissociation of one molecule. And now it's time for the segment you are waiting for, Exam Decoded. Welcome to Exam Decoded. Let us begin with a rapid fire round. I will ask you 5 questions and remember you have only 5 seconds to answer. Here is the first one. If solubility is greater than 0.1 molar, the salt is A. Sparingly soluble, B. Soluble, C. Insoluble, D. None of the above. The answer is B. If the solubility of a salt is greater than 0.1 molar, the salt is soluble. Next question. Solubility and the solubility product is related as A. S is equal to square root Ksp, B. S is equal to Ksp, C. S is equal to Ksp squared, D. None of these. The answer is A. Solubility is the square root of solubility product. For a salt AB, solubility is equal to the square root of solubility product. Good going if you have got it right. Now for the third question. Solubility does not depend on temperature. True or false? False. Solubility depends on temperature. The fourth question. Solubility refers to which type of solution? A. Saturated, B. Unsaturated, C. Supersaturated, D. None of these. Solubility refers to a saturated solution. So, the answer is A. Saturated. Now for the last question, the statement like dissolves like is applicable in terms of solubility. True or false? True. The statement like dissolves like holds true for solubility. Now for the results. If you have got a perfect score, you are a high flyer. Your concepts are quite strong. If you have scored 4 or 3, then you are an achiever. Anything less than 3 and you are a learner. There is still a fair bit of studying to be done, so it's time to hit the books. But just in case you need a break from the books, log on to www.topperlearning.com for revision of all that you have learned today and more. Now that you know the answers, let me throw some light on this topic. This topic comes under the unit equilibrium and has a weightage of 6 marks. So this is critical. Usually, short answer questions worth 2 to 3 marks are asked from this topic, and they are either knowledge based or numericals are asked from this chapter for 2 to 3 marks. So, if you are confident about this chapter, it can really boost up your scores. I know you have a good hold on this topic, but presentation is important too. So, take a look at this question and pay close attention to how it is answered. Here is your question. Lead chloride has a solubility product of 1.7 times 10 to the power minus 5 at 298 Kelvin. Calculate its solubility at this temperature. For 3 marks, here is how you must answer this question. The reaction for PbCl2 may be represented as PbCl2 gives Pb2 plus aqueous plus 2Cl minus aqueous. Writing this balanced equation will fetch you 1 mark. Let the solubility of PbCl2 be S moles per liter. Then the solution will contain S moles per liter of Pb2 plus ions and 2 S moles per liter of Cl minus ions respectively. Hence, the solubility product Ksp of PbCl2 would be given by the expression Ksp is equal to concentration Pb2 plus times concentration Cl minus squared is equal to S into 2S squared equal to 4S cube. This statement will fetch you 1 more mark. Value of Ksp is given as 1.7 times 10 to the power minus 5. Therefore, 4S cube is equal to 1.7 times 10 to the power minus 5. Solving it, we find that the solubility S at 298 Kelvin is 1.62 times 10 to the power minus 2 moles per liter. This will fetch you the final 1 mark. Information from experts always helps. So here are some tips from an expert so that you can ace your exams.
Remember that solubility refers to a saturated solution, whereas solubility product refers to a sparingly soluble salts. Solubility is generally expressed in grams per liter or moles per liter. But when you are solving numericals, you should convert solubility, which is given in grams per liter, to moles per liter, which is done by simply dividing with molar mass of the salt. Also, keep in mind that in examination, the questions on precipitation can be solved by considering the fact that ionic product, when it exceeds the solubility product, then precipitation will occur. This will help you not only in your theory exam but also for viva voce in practical exams. Students normally make the mistake in power or exponent term in the solubility product constant. Please pay attention specifically to the units of the solubility product. Also, when you are solving numerical, do not skip the logarithmic part. This will help you to prepare not only for this year examination but for higher classes also.
That was quite enlightening, wasn't it? If you want to know more about this topic, log on to www.topperlearning.com. Before I say bye-bye, here is something to think about. We all know that barium is a toxic metal. Still, barium sulfate is used in X-rays. Why? If you have been watching the show attentively, you would know the answer. Otherwise, you could always log on to our website www.topperlearning.com and find out. See you next time with another episode of Chemistry.